finding the inverse. This is like the key word. Finding the inverse. There's actually 2 steps. The first step is you're going to go and switch the x and the y. Okay? And the second step, you're going to go ahead and solve for y. Okay? Now, we did this back in algebra, right? If we had, I don't know, f of x is equal to x plus 2, right? This is really saying y is equal to x plus 2, right? Let's say that we're trying to find f prime of x, right? The inverse, right? Then I would just go ahead and switch the x and y. So I'd have x is equal to y plus 2, and then you would solve for y, subtract 2, y is equal to an x minus 2. Okay, very similar, right? But now we're dealing with an exponential. Okay, so I have my function, y is equal to b to the x power. First step is you're going to switch the x and y, so we get x is equal to b to the y power, right? So this guy, solving for y, right, we are going to have to go ahead and in this moment, we are in exponential form. We have to move it into log form. In other words, it has to look something like this, right? What happens is I'm going to say, okay, we're solving for y, so y is equal to, the exponent now becomes, our answer, is equal to the log base b of x. Okay, and this is the log form, right? These two are inverses of each other. Okay, so when we're doing some problems later on, we are going to see, right, some problems that look like this, and I'm going to go ahead and solve it, my thought process, using the exponential form. Okay, so like I said, the definition, this is our log form, log base b of x. Logs are exponentials, right? They have a relationship between logs and exponentials, right? It says log base b of x is read as log base b of x. And we are switching forms, so we are going to go from log to exponentials and exponentials to logs. The way that we look at it, right, here is my log, right? The exponent is the y, the base is the b, right? For exponentials, right, the exponent is our OG exponent, what we're used to, and the base is the number with the exponent. Okay, so there are going to be times where we're going to be going from exponential form, we want to write it in log form, and vice versa. Okay, so I like to go ahead and just write the two functions over here. So exponential form, we have x is equal to b to the y power. Log form, I like to put y is equal to log base b of x. Okay, so I'm going from exponential form to log form. I have 4 cubed is equal to 64. So when I'm putting it in log form, I always have log, right? The 4 then becomes the base. So log base 4 of 64 is equal to the exponent of 3. Okay? The second example, we have log base 5 of 1 is equal to 0. So then the base comes out, so the 5 comes out. Then the 0 now becomes the exponent is equal to 1. And that's true. 5 to the 0th power is equal to 1. Anything to the 0th power is always equal to 1. Right? And then we're going to go back into practice of just writing these from log to exponential. So then the third example, a is equal to b to the c power. This becomes log base b of a is equal to c. Right? Log base x of y is equal to z. This becomes x to the z power is equal to y. Right? The next one, we have y is equal to e to the x power. So we're writing it into log, so I get log base e of y is equal to the x. Now I'm going to tell you right now, log base e does not exist. This is actually a special case where log base e is actually ln of y is equal to x. So log base e is equal to the natural log. Natural log. Cool. And the last one, we have ln of a, so the natural log of a is equal to b. This just says that here there's a sneaky little e, so to say. So I have e to the b power is equal to a. Okay, so that's how we write from exponential form to log form and vice versa. Example 1, now it's asking us to go ahead and actually evaluate each of the following problems. Okay, when we start with logs, I like to go and think about it in terms of my exponentials. So I'm going to go and hop around. I might not do every single example. You guys can go and look at the answer key to fill out the rest. Right, so for part A, it says log base 2 of 4 is equal to what? Right, I'm going to go ahead and write this log form into exponential form. So this becomes 2 to whatever we're finding. So 2 to the x power is equal to 4. Then you're just asking yourself, okay, what is x, right? 2 to what power gives me 4? That's just 2, right? Same thing for part B. Log base 3 of 1 is equal to what? This becomes 3 to the x power is equal to 1. 3 to the 0th power is equal to 1. Okay, if I go to part E, same thing, 5 to the x power is equal to radical 5. I can go and rewrite this one as 5 to the x power is equal to 5 to the 1/2 power. And then I know, okay, we're going to talk about this a little bit more. These two have the same bases. What happens is I can actually go ahead, right, cross things out. X is equal to 1/2. And I think, yeah, this was this property right here. The bases just cancel out. Right? Number F, or part F, right? 6 to the what power gives me 1 over 6. I can rewrite this one as 6 to the x power is equal to 6 to the negative 1st power. Same thing, cancels out. X is equal to negative 1. Okay, D and H might be a little bit trickier. You guys can look at part D. My hint to you, right? 3 to the x power is equal to radical 27. I would rewrite this radical 27 in terms of 3, right? I know that 3 cubed is 27, so that's my little hint to you, okay? Part H, though, however, this one's a tough one, so let's go and try it. So I get 4 to the x power is equal to 32, right? Now, these might not have the exact same base, right? I'm going to go and look at in terms of like what I could do with the 4, right? The 4 can become 2 squared, right? So this becomes 2 squared of x, or 2 squared of x, or 2 to the power of 2x is equal to 2 to the 5th power, right? Same exact thing, same bases. So all I'm really doing is 2x is equal to 5, x is equal to 5/2. Okay. And that is when we are going from log, finding out these logs. Okay. Now there are special log bases. We kind of already talked about this first one. When I have log base e of x, we don't like to write it as log base e. We like to write it as ln of x. ln of x is that natural log. Natural log, right? There is also what's called the common log. So whenever I have log base 10 of x, whenever it has a base 10, you can just write it as log of x, okay? They are the same thing, especially when we get to the next section of notes. You are gonna have to write log multiple times. If it has a base 10, you could just write log of x, okay? So example 2, we have to simplify each expression. Now we have to go ahead and we are in exponential form, maybe some logs as well. But let's just go ahead and evaluate each one of these. Part A, right, we have the natural log of e. I like to go ahead and put in a little sneaky little e, and then I'm going to think about it in terms of our exponential, right? I'm going to go back and I'm going to say, okay, e to what power gives me e, right? E to the x power is equal to e to the 1st power. Same bases. X is equal to 1. All right, same thing with part B. We have ln of 1, so I'm going to put my sneaky little e. Same exact thing. I'm saying e to what power gives me 1. Anything to the 0th power gives me 1. Right? I want you to try C and D. Going to part E, right? It says log of 100 is equal to. This is that common log. So it's really log base 10 of 100. So same thing, I'm going to think about it in terms of exponentials. 10 to what power gives me 100? That is 2. Right? Same thing with part F. It says log of 0.001. So this is the common log. So it's really log base 10 of 0.001. Right? So in terms of decimal, right, this we can rewrite it into a fraction. So I could rewrite this problem as log base 10 of 1 over 1,000ths, right? The decimal's in the thousandths place. And then I can keep going, I keep simplifying this actually. Log base 10 of 1 over 10 cubed, right? So then I can even keep going, guys. Wow. Log base 10 of 10 to the negative 3rd power. Right? This answer is actually -3. Okay. It's kind of like rethinking of how can I express this in terms of my exponent? Okay. Very similar with part G. Go ahead and try that one. The one that I do want to talk about is part H. So I have log of 10 cubed root of 10. That's a lot, right? Again, this is the common log. So log base 10 of 10 cubed root of 10, right? Same thing, 10 to what power is equal to 10 cubed root of 10. Right? I'm going to go ahead and rewrite this side. So I'm going to keep the 10 power of x, right? My unknown. This becomes 10 to the 1st power. Right? That's this guy right here is 10 to the 1st power. Times 10 to the 1/3 power. And that's this guy right here. Right? And then I have something where it has 10 to the 1st power